Hello everyone. So now let us discuss the solutions for question number 76, like starting from question number 76. So the first question here is, we can see the compound that will undergo SN1 reaction with the fastest rate is. So in this question we need to tell out of which of the following the one that will undergo SN1 reaction fastest. So we know that the rate of reaction for the carbocations for SN1 is tertiary, then secondary, then primary, because whenever tertiary carbocation is formed, the compound will undergo SN1 reaction fastest. So in this case, in the first case, you can see yes, this secondary carbocation is formed, but this is phenyl carbocation. It is actually unstable, so the reaction will not be as fast. In the second case, yes, this carbon is there, here carbocation will be formed, so here it is secondary carbocation. In the third one, it is primary carbocation, like here it will be formed, so it will be primary carbocation. And in the second case also it will be phenyl carbocation. So we will see here that the secondary carbocation will undergo the reaction fastest. So that is why we can say the correct answer is option number 2. Now let's go to our question number 77. The energy of an electron in ground state, that is for helium He plus ion, is minus x. Then for the electron in n equal to 2, that is for beryllium 3 plus ion, would be. So students, we all know here that the energy, that is En, is given by minus 13.6 z square upon n square. So we can calculate for helium ion, so that will be E1. So minus 13.6, atomic number of helium is 2, so 2 square, and n is 1. So clearly we can say it is minus 13.6 into 4, and this value is given to be x, right? So then for beryllium we can find it out similarly, 13.6 z square. Now for beryllium the atomic number will be 4, so 4, and for second orbit we have to find n, so it's n 4 square upon 2 square, so minus 13.6 into 16 upon 4, so it is also coming out to be 13.6 into 4, means both the values are same, means if this one is x, and so this one would also be x, like, so the answer would be option number 3, that is this will be the energy. Now question number 78, in which of the following processes entropy increases? So we know that entropy is the measurement, or you can say, of randomness, or the order of randomness. So when a liquid evaporates to vapor, so here the liquid is being converted to gas. So in gas there is more randomness, the particles are far from each other, so yes, here the entropy would increase. Temperature of a crystalline solid is lowered from 130 to 0 Kelvin. Now students, as temperature decreases, we know that the particles in solid vibrate less and become more ordered. So here there would be more ordered arrangement and the entropy will decrease. So in second case entropy would decrease. Now the third one is 2NaHCO3 gives Na2CO3 CO2H2O. Here we can see there are 2 moles, but here we are having 1, 2, 3 moles. So if number of moles are increasing, entropy will increase. Here also we have 1 mole of chlorine molecule, but here we have 2 moles of chlorine atom. So again entropy will increase. So entropy is going to increase for A, C and D. So that is the answer, 78. Now next up is 79. On heating, some solid substances change from solid to vapor state without passing through liquid state. The technique used for purification of such solid substance based on the above principle is called. So this is very easy. We all know that when solid directly converts to gas without passing the liquid state, this process is called sublimation. So yes, the technique that is used for purification of such substances is called sublimation only. So answer is option number 4. Now let us move on to question number 80. Here we have been given some coordination complexes. We have to tell the type of isomerism. So in the first compound, basically it will exhibit linkage isomerism. So here you can see that NO2 is there. So linkage isomerism is there where the ligand can bind to more than one atom. Okay, so it is NO2, so it can either bind through nitrogen or it can bind through oxygen also. So this will get different isomeric products. Next is second one. So here bromine is out of the coordination sphere. So this will represent ionization isomerism. That is the third one, because when this compound will ionize, the counter ion, this can be exchanged with the sulfate. So here sulfate and bromide can exchange and we will get different ions. So that is why it is giving us ionization isomerism. Next one. Now here you can see that this compound, it is going to exhibit coordination isomerism. Now coordination isomerism means where both the cation and the anion are present in a complex compound. Okay, like both the cation and anion are complex ions, like here we have NH3 and here we have Cn. So NH3 can be exchanged with the cyanide, okay, the cyano group, leading to different isomeric compounds. So it will be coordination isomerism. Next is the fourth one. So it will exhibit solvate isomerism. Okay, because what are the solvent molecules attached here? Here the chlorine can be associated with different number of water molecules. So here we will be getting different compounds or different isomeric products. So we can clearly see the answer would be A2, B3, C4, D1. So answer is option number 3. Next up is question number 81. So class, in question number 81, it says aniline does not undergo Friedel-Crafts reaction, Friedel-Crafts alkylation reaction, and statement 2, aniline cannot be prepared through Gabriel synthesis. So yes, aniline does not undergo Friedel-Crafts alkylation because it's a base, and in Friedel-Crafts alkylation we are using anhydrous AlCl3, which is acidic. Okay, it's a Lewis acid. So they can undergo acid-base reaction, and moreover, because of NH2 group, aniline is a pure nucleophile, poor nucleophile, and it deactivates the benzene ring towards electrophilic substitution reactions. Okay, aniline cannot be prepared through Gabriel synthesis because Gabriel synthesis is used for primary alkylamines, not for aromatic amines. Okay, so that is the case. Or like we get this type of complex in Gabriel synthesis like this, C double bond O, C double bond O, N minus K plus. So it actually reacts with Rx. So here if it is aniline, this cannot be done. Okay. So yes, the answer is both the statements are true. Next question, class, 82. Arrange the following in increasing order of first ionization enthalpy. So yes, what happens is, we know that when we are moving left to right in a period, the ionization enthalpy increases. Yes, because the electrons are tightly bound to the nucleus because of increased nuclear charge, so more energy is required to remove the electrons. So that is why the ionization enthalpy would increase. So the order would be lithium, beryllium, boron, carbon and nitrogen. But what happens in the case of beryllium? Beryllium is 1s2, 2s2, and boron is 1s2, 2s2, 2p1. Now beryllium has this fully filled electronic configuration. So it is pretty difficult for us to remove the electron from the outermost shell of beryllium. So that is why the order becomes lithium, then boron, then beryllium, then carbon and then nitrogen. So boron will have less ionization enthalpy than beryllium because beryllium has this stable configuration. So that is why the answer would be option number 4. So this was the point of confusion in this case, like we would have chosen otherwise option number 3, but the anomalous behavior is there in the case of boron and beryllium. So this was the point of mistake in this question. Now the highest number of helium atoms is in. So we have given the different things for helium. So 4 gram heliums. Now 4 gram helium means we know we can find the number of moles in each case. So the molecular mass or the molar mass of helium is also 4. So given mass is 4, molar mass is 4. So it means it's 1 mole. Okay. 2.27 liters of helium at STP. So we know at any gas at STP acquires 22.7 liters or 22.4 liters of volume. So according to that also it will be around 1 mole. And in the third case we are directly given 4 moles of helium. And for fourth option it's 4 atomic mass unit. So 4 atomic mass unit, again it corresponds to 1 mole. Okay. So if it is having 1 mole, so we can clearly see that in option 3 we have 4 moles. In other options we have 1 mole. So 4 moles of helium will automatically have 4 into Na, that is Avogadro's number of atoms. So the most number of atoms are in option 3. So answer for 83rd question is option number 3. Next is question number 84. We have to find out the most stable carbocation in this case. Okay. So actually the most stable carbocation, it will be assessed on the basis of number of hyperconjugation structures that can be formed. So basically we need to see how many alpha hydrogens are there in this case. Okay, so more the number of alpha hydrogen, more will be the hyperconjugative structures and more would be the stability. So here we have only one alpha hydrogen. Okay, like this is CH2, so this carbon is attached to one hydrogen. Here this is the carbocation. So here we have three, like it's 3 here and 1 here, 1 here, like 2 and 2. So 3 plus 2 plus 2, like it's 7 alpha hydrogens in this case. Here we will be having CH2, here we have CH, here 3 alpha hydrogen, here 3 plus 2, 5 alpha hydrogen. So clearly we can see in second structure there are 7 alpha hydrogen. So most number of hyperconjugated structures would be there. So answer is option 2. Question number 85 is given. Henry law constants are given for 3 gases. Solubility of these gases we have to tell. So clearly we know that Henry law constant, it indicates the solubility of gases in a solvent at a particular temperature, and solubility is inversely proportional to Henry law constant. Okay, so clearly we can see that A has the highest value of Henry law constant. Okay, then it's followed by, now here we can do it in the case of C. So C, again C is 35 kilobar. So it's A, then C and then B. This is the order for Henry law constant. So the order of solubility would be reversed, that is B, then C, then A. This is the order of solubility. That is, it is reversed. So the answer is option 4, B, C and then A. Next question number 86. This is from section B. A compound X contains 32% of A, 20% of B and remaining is C. So 32% A, 20% B, remaining is C. We need to tell the empirical formula. Atomic masses are given. So if 32%, let's say we are having 100 grams of the compound. So A is 32 grams, B is 20 grams. And then C would be 48 grams. So firstly we will find out the number of moles. Number of moles means given mass upon molar mass or the atomic mass, whatever is given. So we have got number of moles of A, B and C. Now find the simplest whole number ratio. So 0.5, 0.5 and 1 we have got now for A, B and C. So divide it with 0.5 only. It's 1.5. So it's coming out to be 1, 1 and 3. So it means the formula will come out to be A, B, C, 3. It's option number 4. Okay. Next is question number 87. Okay, so it's like a product A and B in the reaction. So in the first reaction, alcohol is reacting with phosphorus trichloride. So the products would be the alkyl chloride plus phosphoric acid, which is H3PO3, And when it reacts with phosphorus pentachloride, we get the alkyl chloride plus phosphorus oxychloride and HCl, of course. So it's a phosphorus oxychloride. So A is H3PO3 and B is POCl3. So answer is option 2. Question number 88. The plot of osmotic pressure versus concentration gives a straight line, and which is having the slope 25.73 liter bar per mole. Temperature at which the osmotic pressure measurement is done. So we need to tell R value is given. So basically we know that the osmotic pressure is given by pi is equal to CRT. If we compare it with the straight line equation, y is equal to mx plus c. So pi, y is pi here, and we are plotting it against temperature. So x is temperature, c is 0. It means the slope is c into r. Okay. Alright. Okay, so we are plotting it against concentration. So yeah, x would be your concentration like this, and the slope would be r into t. Value of r is given. We can find out the value of m is also given. We can clearly find out the value of temperature T, which is 310 Kelvin, and comparing it to 30, like converting it to degrees Celsius, it comes out to be 37. Question number 89. Firstly, here we are having an alkene, right? So we need to tell the major product in this case. So whenever an alkene is there now, and in acidic conditions, what happens? This will break down. This double bond will break and we will get a ketone. So yeah, 2 molecules of ketone would be formed like this. Okay, like aldehyde in this particular case means this double bond will break and we'll get a double bond O in this case. So 2 such molecules will be formed. Now this is aldehyde. So what will happen in the presence of KMnO4, which is a strong oxidizing agent? This will get converted to carboxylic acid. Of course 2 moles. So yes, the answer would be option number 4. Okay. Next is question number 90. So there are some coordination complexes given. CONH3 3 plus is a homoleptic complex, while CONH3 chlorine Cl2 is a heterolytic complex. So yes, students, homolytic complexes are the ones which have identical ligands, whereas heterolytic complexes are the ones which have more type of ligand, more than one type. So yes, this one is having ammonia. Here it is chlorine also. So this is correct. This is homoleptic. This is heteroleptic. So yeah, this is also true statement do that this has only one kind of ligand, but this one has more than one kind because we are having ammonia as well as chlorine. So both the statements are true. Option 3 is the answer. Now during the preparation of Mohr salt, which is ferrous ammonium sulfate, which of the following acid is added to prevent hydrolysis? So since we are having sulfate now, ferrous ammonium sulfate, so to prevent the hydrolysis of ferrous ions and aluminium ions, we are adding dilute sulfuric acid. Dilute nitric acid will oxidize, no? But dilute sulfuric acid would be added to prevent the hydrolysis. Since it's ammonium sulfate, ferrous ammonium sulfate, so we'll be adding dilute sulfuric acid. So it's option number 2. Question number 92. Identify the correct answer. Dipole moment of NF3 is greater than that of NH3. So actually what happens in the case of NF3? So in question number 92, what happens is in the case of NF3 and in the case of NH3. So if we see the net dipole moment, in the case of NF3, it is having opposite direction. Okay, like it is having opposite direction, but in the case of this one, your NH3, it is in the same direction. So yes, the dipole moment of NH3 would be more than NF2. 3. So this is wrong. 3 canonical forms can be drawn for carbonate ions. So yes, for carbonate ions we can draw the 3 canonical forms. So this is actually true. 3 resonance structures can be drawn for ozone. So this is not true because there are 2. And BF3 has non-zero. No, BF3 does not have a non-zero dipole moment. It is having zero dipole moment because it's a planar molecule, and the dipole moment, they cancel each other. So this is also wrong. This is also wrong. Correct answer is option number 2. Okay. So it's 2 now. Now next up, 93 question number. We have to arrange the given ions from group 0 to 6 if we look at these ions here. So in question number 93, the answer is option number 3. So the first one, it would be copper. Copper ions that are belonging in the group number 2. Then it's aluminium ion in group number 3. Then it's D, that is your cobalt in group 4. Then we have your next one is barium ions, and if no group is present, so it's like group 5, and for magnesium it's group 6. So the order is option number 3. Next is identify the major product C formed in the following reaction sequence. So here it's an SN2 reaction. Iodide, okay, let's write. So firstly, when this idopropane, it reacts with NaCN, we will get this product CHCN. Then partial hydrolysis. So on partial hydrolysis of cyanide, what we will be getting is an amide. And then after NaOH-Br2, so Hofmann bromamide reaction will happen, and we will get an amine. So CH3, CH2, CH2, NH2, we are getting an amine here. So propylamine is the answer, option 3. So 95th question, here it's a numerical. So the rate of reaction quadruples. Quadruple means becomes 4 times when temperature increases from 27 degrees to 57. Calculate the energy of activation. So the activation energy, we can say that it will be given by, we can use this Arrhenius equation, log K2 upon K1 equals EA 2.303 R 1 upon T1 minus 1 upon T2. So yes, here we'll add 273, so it's 300 Kelvin, and T2 is 330 Kelvin. K2 and K1, so you can say that K2 is 4 times K1 because it is becoming quadruple. So when we solve this, put the values here. R value is 8.314, log 4 value is also given. So when we, because here we will get log 4 K1 upon K1, so this will cancel and we'll get log 4. Log 4 is given. So from here, the energy of activation will come out to be 38.044 kilojoule per mole. So it's option 3. Question number 96. In the reaction of a sealed vessel, the dissociation of nitric oxide is happening. 0.1 mole per liter of nitric oxide is taken. So we need to tell that what will be the degree of dissociation, that is alpha. So the concentrations are given. Firstly, we will be finding out the value of Kc for the reaction. So Kc is like the product of the concentrations of the product side, this one, N2 and O2, divided by NO. Since the coefficient is 2, so it will be square. When you solve it, it will come out to be 1.607. Okay, so now this is happening. 2NO is dissociating to give so 2NO is giving us N2. So we can write it like this. 2NO is giving us N2 plus O2. So if it's like C minus alpha, here we can say C into 1 minus alpha, then it's alpha if alpha is the degree of dissociation. Okay. So if we take it like this here, means how much it has been dissociated. What we can take is, let's say if x much has been dissociated, so it will be x by 2 and x by 2. So alpha is the degree of dissociation, means how much is dissociated divided by total concentration, which is x upon c. So here we can say x is c alpha. So it will become c minus c alpha. It will become c alpha by 2 and it will also become c alpha by 2. Now we will put it in the Kc value. Let's do it here. So we will be putting it. So product like this divided by reactant. So reactant is C into 1 minus alpha we can write. But here we have to do square. Okay. So C will cancel out. We will get alpha square upon 4 into 1 minus alpha square. That is 1.607 we have got the value of Kc. While solving it, we will solve it and the value of alpha will come out to be 0.717. So it's option number 2. Okay, and 96th question, change it as option 2. Now, 97th question. Work done during reversible isothermal expansion of 1 mole of hydrogen gas at 25 degrees from pressure 20 atmosphere to 10 atmosphere. So that is the case here. So work done will be minus 2.303 nRT log P1 upon P2. So all the values are given here in this case. We will put the values, okay, because the answer is in calories. So R is 2 calorie. So we will solve it and the value will come out to be 413.14 calories in negative. Okay. So yeah, it's in negative. So 0.5 we will do log 2. So it comes out to be 413.14, which is positive. Okay. Next is 98th question. We have to find out mass in grams of copper deposited by passing this much amount of current through a voltmeter containing copper sulfate for 10 seconds. Okay, so firstly we will find out the charge, which will be current into time. So the charge is coming out to be 964.87 coulomb. Now number of moles will be Q upon ZF. So Z is 2 here, means the number of electrons, because copper gets deposited like this. So it will be 2. Q is given 2 into value of F is given 96487. So we'll solve it. It will come out to be 1 upon 200 moles. So the mass of copper would be its atomic mass into number of moles. So it will come out to be 0.315 grams. So it's option 4th. Next is, here we have to tell the major product in this reaction. So PBr3 here is given now. So it will be acting on the OH only. It will not act on the methyl group. So OH gets replaced by Br. So we will get this product first. CH3 and Br. Now we are adding alcoholic KOH and heating it. So of course elimination reaction will happen because we are adding alcoholic KOH. So elimination will happen. This Br will get removed and hydrogen from here will get removed. So we get a double bond at this position, CH3 and a double bond. So let's see the product. It's option 3, this one and this one. Last question, pair of lanthanoid ions which are diamagnetic in nature. Diamagnetic means which are not having any unpaired electrons. All the electrons are paired. So here in this case what will happen is that cerium 4 positive, because cerium is 4f1 5d1 6s2 and we are having ytterbium, it's xenon 4f14 6s2. So cerium 4 positive would be, all of this will be removed, means 4f0, and ytterbium 2 positive would be 4f14. So here both of these will have no unpaired electrons, others will have. So cerium and ytterbium, it's option number 3. That is the right answer. So I hope you have understood all of the solutions. Thank you so much.